Let's get started. Hello, everyone. Welcome to the deep dive session of CNCF hosted project Harbor. I'm Steven Zhou, Harbor maintainer. Currently, I'm working at VMware Beijing R&D Center as a staff software engineer. Today, in this session, I will co-speak with another Harbor maintainer, Daniel Jiang. Daniel.
Hey guys, this is Daniel. I work in the same team with Steven.
Okay. We are so glad to have this chance to share with you some of the latest updates and the related development plan of both Harbor project and the Harbor community. Before formally start, I'm so glad to share with you the excited and great achievement for the whole Harbor community. We Harbor graduate. Harbor becomes the 11th graduate project. Obviously, this achievement belongs to the whole Harbor community, belongs to all of you, Harbor users, partners, and contributors. Really appreciate. Graduation is not the end, but a totally new starting point. The Harbor community will work harder and continue to push the project forward more quickly and healthily. Here is today's agenda. It mainly has the following parts. First, I will quickly update the latest states of the Harbor community. Next, Daniel will give you a review of the key features changes we delivered in the latest major release 2.0 and highlight the anchor features that would be released in the upcoming major release 2.1, including non-blocking GC and proxy cache. Later, I'll take over and continue to introduce some other 2.1 release like P2P preheat and extended processor. These features are led by the community work groups. Finally, I would like to share with you some of the long-term planning directions. That is our roadmap. We'll leave several minutes for Q&A after the presentation. Let's take a look at the latest status of Harbor community. One little tip, the data shown in this slide are from the Dev States website powered by the CNCF and the inside page of GitHub. It can be clearly seen from the data that Harbor community is thriving. Overall data shown at the left side, till mid of July, we have gained 12,300 stars at GitHub. Now, we have more than 200 committers. About our maintainer group, there are 14 maintainers across 5 companies located at 4 countries. More details shown at the right side, they can give us more insight of the community liveness. We have more than 50 contributing companies. We have more than 3,000 contributors. We also have more than 4,000 folks, more than 12,000 commits. Okay, in the past 2 weeks, there are 60,000 views to the GitHub repo from more than 11,000 visitors. And the related package have been downloaded more than 5,000 times in the past 2 weeks. The bottom curve graph shows the fact that the project is actively maintained, and we can get many commits every day from different contributors. Okay, I'll hand over the time to Daniel to talk about what we delivered in the 2.0 and what we have anchor features in the upcoming 2.1. Daniel.
Okay, thanks, Steven. Guys, as for now, the Harbor v2.0 has been released for some time, but let me take a couple of minutes to recap the key changes we brought in this release. In v2.0, we extended Harbor's scope from managing container images or Helm charts to all OCI artifacts, including the charts packaged by Helm v3 in OCI format, OPA bundle, CNAB, etc., etc. And these artifacts will be stored in the single registry instance, coexist in the repos of Harbor, and restricted by the same permission rules, as long as they can be pushed and pulled by the distribution v2 API. And this allowed us to use the same code path and workflow to manage all types of artifacts, such that the policies we introduced to manage container images, such as replication, tag retention, immutability, will still be applicable to the new artifacts as well. Because we now see the abstract artifacts as the object for management, we managed to introduce an extensible approach to process the requests to push the artifact to Harbor, to extract and display different attributes based on the type of the artifacts. And this is an extensible framework. And you'll see later in this presentation that in the version 2.1, our partners in community will leverage this framework to enable Harbor to manage the machine learning model they developed. And in addition to that, with the new artifact model, we fixed the historical issues that Harbor cannot manage manifest list correctly. Now the manifest list or image indexes can be pushed to Harbor and served or managed as a special artifact, which has reference to other artifacts. Last but not least, we also made other enhancements in version 2.0. For example, maintainers from Aqua Security introduced the integration with new scanning tool Trivi, and you can enable TLS communication for internal components during installation, etc. So with that said, if you haven't upgraded to 2.0, please go check it out and give us feedback. There are lots of cool stuff there. Okay, now after the recap, we'd like to introduce a few interesting new features that will be provided in 2.1. First, the new garbage collector. As we know, in the registry, the layers or blobs are shared across images. So when an image is removed, the storage taken by the blobs can't be freed because they may be referenced by other images. Even if the reference count of a blob is 0, in concurrent scenario, an image referencing this blob may be being pushed to the registry at the same time you do the deletion. Therefore, currently we need to put Harbor in read-only mode and trigger the distribution's GC command to delete the blobs and free the storage. But there's this one disadvantage of this approach. The distribution needs to walk through all the images to find out which blobs can be garbage collected. And when the number of the image is huge or the backend storage is relatively slow, Harbor will stay in read-only for a long time. Sometimes it's too long to be acceptable. So we want to see what we can do to mitigate the problem. Considering in 1.9, when we introduce the quota management, to calculate the storage usage, we keep track for all the blobs and their relationship with artifacts and projects. With this data, we can figure out the reference count of blobs with a relatively low cost. So you don't need to walk through all images in the storage. Additionally, we have the database. We can take advantage of this strong consistency. We introduce a mark and sweep strategy to avoid the problem in concurrent scenario. And in the GC job handler, it will access the storage directly to remove the blob instead of relying on the distribution command. So GC can continue without having to put the whole registry into read-only mode. So you can do push or deletion while the GC is running. Additionally, leveraging the information we have in the DB, we can provide estimation to administrator about how much storage will be freed after the GC is completed, which should be very helpful for admins to decide whether or not to apply for new storage or run a GC to free storage. And this feature has been demoed and reviewed in our community meetings. The code has been merged to master branch as I'm doing this recording. But hopefully, by the time you see this video, there is an RC for 2.1 for you to try. Next page, please. Another feature I want to mention is the proxy cache. We noticed there have been asks from many users who want to set Harbor to mirror to mirror images from Docker Hub, such that Harbor can act like a proxy, and the user can pull images from Docker Hub in air-gapped environment. We know you can set distribution to mirror mode, but there's a limitation that the mirror mode distribution is read-only. You cannot push images to it. And we cannot simply bring up two instances, one is mirror and one is readable, because once the URIs clash, the images will override one another. And we used to think with a pull mode replication, such requirement can be addressed. But the experience was not good enough because the replication is a async job, and not until the job is successfully finished can the image be available for pulling. Additionally, there's no guarantee that the images are up to date because when it's updated on the Docker Hub side, Harbor can be notified. So in 2.1, we introduced extra attributes at project level. So you can associate a project with a registry endpoint used for replication. When you issue pull command to the URI from under this project, a middleware will trigger part of the replication code so that the images will be pulled from the remote registry. And the content will be served to the client at the same time it's written to the storage. It's just like the T command. And like the regular project, you can apply tag retention, quota management policy to control the storage usage for the proxied images. And you can even trigger a scan to find out the image proxied, whether do they have any vulnerabilities. Because the proxied image are local. So we reuse the code in replication adapters under the hood. So theoretically, we can proxy images from all registries that we can do replication. But due to limited time for testing, in 2.1, you only can proxy images from Docker Hub and other Harbor instances. When we have a solid framework to test all the replication adapters, we'll enable proxying other type of registries, such as ECR, GCR, etc. I think this feature will not only benefit the air gap scenario, but also in the edge scenarios. When you only push image to the central registry, you can issue pull command to the edge registry, and it can work as an on-demand or lazy replication. And at the time of recording, this feature has also been enabled in master branch. And it's available in the dev build already. It will for sure be part of 2.1. Okay, that's my part. Let me hand it back to Steven for other cool stuff and work group in version 2.1. Steven?
Okay, thanks Daniel for the wonderful introduction. Besides the two anchored features, the non-blocking and the proxy cache introduced by Daniel just now, here I'd like to highlight another two features introduced in the 2.1 release. The first one is P2P preheat. As we know, P2P can help to accelerate the content distribution process. The CNCF project Dragonfly and the Uber OSS project Kraken both use P2P technology to support efficient container image distribution process. Preheat will provide a lightweight way for users to leverage the capability of the P2P engines like Dragonfly and Kraken to accelerate the image distribution process. With preheat, users can register the API endpoints of their P2P engines into Harbor and then targeting the registered P2P engine. A policy can be created to specify what images are qualified and ready to distribute into the P2P network cache in advance. Caching the image content into P2P network in advance can make sure all the data pieces required by the P2P network has been there and no need to download those first copy data from the source registry. This can reduce the latency when pulling requests happen in the P2P network. Multiple filters and criteria can be set in the policy. Use repository filter to narrow down the image repository. Use tag filter to narrow down the text of the matched image repository. mark only send image to only allow image with signature to be preheated. Set a vulnerability severity bar to make sure only the secure image are accessible. Provide labels to limit only image with the specified labels can be selected. The policy can be enforced by a preset schedule or based on the related events like onPush, onLabel, and scan complete. The feature is designed and developed by the P2P work group. Members are from VMware, Alauda, Tencent, NetEase, Alibaba, and Uber. Great thanks to them. The next one is extended artifact processor. And we introduced in the previous slide, Harbor supports managing and distributing the artifacts that following the OCI spec from 2.0. Besides the basic info of the OCI artifact, Harbor also defines a metadata processor interface to extract more metadata from the configure or content blob of the OCI artifact and return those extra data in the Harbor API. However, currently, Harbor only handles some of the well-known standard artifact kinds like Helm v3 chart or CNAB by implementing specified metadata processors. For the non-standard, that is user-defined OCI artifact kind, and no relevant processor existing, most of the metadata cannot be extracted out. This shortage makes Harbor lack of extensibility. In 2.1, we extended the default processor to identify the non-standard artifact kinds, not Helm v3 chart, not CNAB, and not OPA bundle, and extract the related KV metadata from the configure blob and other content blob that are marked with specified annotations, and also return those extracted data in the Harbor API. What annotation we can use and what do they represent will be defined into a simple metadata spec for user to refer. This feature is led by the CloudCloud team. With this feature, user can build their own specified artifact management and distribution platform on top of Harbor. For example, like feature contributor CloudCloud doing an OCI compatible machine learning model management platform. Okay, after talking about the features of 2.1, let's see more long-term plan items in our roadmap. The plan items are grouped into three perspectives: management, distribution, and extensibility. The items highlighted with white color are the ones we have already been working on in 2.1, like non-blocking, proxy cache, P2P user-defined artifact processor, and one more vulnerability scanner from Sysdig. About a Harbor operator, OVH Cloud team has contributed the first version of Harbor operator, the version 0.5. Now they are working on the release 1.0 that includes lots of excellent improvements. It should be ready recently. Based on the Harbor operator, the operator work group of Harbor community has started the work to build a Harbor cluster operator. The goal of the Harbor cluster operator is deploying Harbor with all its dependent service, database, Redis, storage in a HA mode. The first version of 0.5 should be ready before end of August. Before such ongoing items, we are also looking at Windows containers, improve support for Windows container layers, observability, expose Harbor metrics through Prometheus integration, networking, support an IP version 6 only network for Harbor ports in a Kubernetes cluster. Okay, backup and restore leverage Velero to offer application-aware Harbor backup, including database, Kubernetes, objects, and persistence volumes. Identity and access management and RBAC will do some research on service accounts with proper RBAC and differentiated access permissions. Improved the multiple tenants through ability to manage teams of users and robot accounts through workspace. Okay, welcome to do collaboration with Harbor community. We have several ways for you to involve in the community. You can join the Slack CNCF workspace and find us in the Dash Harbor channel, that's for user, and the Dash Harbor DEV channel for development. Or send a mail to us or follow Harbor in Twitter. We have bi-weekly community Zoom meetings to update the latest state of Harbor project and the community, or do preview demos of the new features. Welcome to join. There are 2 time slots, one for Asian Pacific plus European and one for Americans plus European. You can find the meeting details in the README of Harbor project and GitHub. Furthermore, we have deployed a demo environment for you to have a try. Just access demo.goharbor.io. So that's all the content of this presentation. It's a Q&A time. Any question, we are here and listening to you. Thank you.